Yeah, I can.
You can see me? Okay, great. So welcome everyone. And I'm speaking to the camera as well as those in the room. We're very excited to present as far as the 2025 Gothic Research Seminar Series. We have two gentlemen from South Korea who are doctoral candidates that are here to present their research. And we're very excited. And I think they'll agree. I hope you don't mind as we go along to if we ask questions. And I know you have a lot of material to go through, but hopefully this is we have some interactivity here and can get some great discussions going. I am Professor Cotillo, and just introducing myself, we have a few other professors here in the audience. However, I don't think the cameras can reach out into the audience, so I'm just will tell you everyone's here with smiles on their face and looking forward to this presentation. So we're going to give the second presenter a great job. So love the questions. 2 minutes to set up. If people in the room, if you want to grab something to eat, drink. And for those on the Zoom call, and those will be for the second presentation. I saw there were a couple questions about sound, things of that sort. I did not notice if there were specific questions about the presentation, but for the second one also, feel free to put something in the chat to further inquiry, any thoughts, things of that sort. So we're gonna get ready to go, and we'll start in 2 minutes. Thank you.
Yes. All right. So now let's gonna get started for the second presentation. And I'm from South Korea and from Korea University Business School as well, like Taiwan student, the PhD candidate. And then we're gonna starting the presentation about the AI-driven dynamic scenario planning for demand forecasting. And thank you so much for being here. Thank you so much for your time to attend this meeting, a research seminar. And then thank you for you guys from the Zoom as well. And uh, actually, this study is kind of like a project level. We want to build up as like a research level, but we are kind of in a way that we can figure out whether what kind of a good idea that we can actually develop this topic as into academic level. So we are thinking about maybe we can conduct some like another like empirical method and then make a comparison in between what we have done and then the existing method so that we can figure out whether our method could be better or maybe what is the difference in between among the existing methodology and the one that we created. So let's gonna get starting from the first slide. Actually, I want to starting from the slide that introduction of myself. So about myself, my name is JungwooPark, and I'm from Korea University Business School as well, like some of them can PhD candidate. And then we actually finished the master's and the PhD course together. And then my research interest is about service operations or like a quality management or operations management. And I also published a paper about the servitization and the quality management, which is I use the proactive quality management method. But I'm going to explain about what is the concept of the proactive quality management later. And then I got some award about the quality excellent paper award from the Korean KCI journals. And then it's about the understanding concept of the proactive quality management in its case. And currently I'm working on like several papers about like profitability or like a long-term reactions or something for what's the benefit of the programs or innovative tools and things like that. So I'm going to explain a little bit more in detail in the next slide. So the research I do is the first one is a service guarantee program. So when we come up with the idea about the service guarantee program, which is that the firm, they are willing to guarantee their best service to the customers, even though they consume their resources. Like literally, maybe they can pay for your like I said, customer satisfaction, or if you're not really satisfied from the service that we conducted, then maybe the customer can charge us some like money or things like that. So we are basically promising the firm for service providers. They are promising the compensation to the customers if the customer they didn't really have the set if even if they are not satisfied from the service that they provided. So actually, there's many types of the things that on the side. But let's focus on what's the effect about the service guarantee program. So the service guarantee program has a long-term, long-run effect that actually shows the ROA and the Tobin's Q, those financial performance got well. And you can come up with the idea about the like a real business example as a JetBlue. So they are actually mentioning about the customer satisfaction, about the compensation. If there is any sort of delay, then they promise to the customer the compensation on their website, and maybe you can figure out from their service site as well. So this is the kind of concept about the service guarantee program. But the reason why we conduct the research about it is because service guarantee program, it could be costly. So we just checked whether it can make money or not. And the second one is about the proactive services. This is also like a kind of concept that we provide the service more proactively. It's not like after service failure happens or after service failure occurs, then customers, they are already unsatisfied. So that's why we conduct the proactive service. It could be costly or it could manage the customers' satisfaction well. So we also conducted like a financial performance analysis, and it came out as a by the event study. It came out well. And you can see the real business example from Verizon. They have a call filter, and then when they have a call filter, then they can actually filter the many sort of the spam or things like that, so that they can actually protect the customers, and then they can actually achieve the proactive service to protect their maintain the customer satisfaction well. And the next one is about the concept of the proactive quality management. And its case is kind of related to like a proactive service that I mentioned, but we also managing the quality in advance. When you see the time frame of the quality management, there are process and there are product development. The proactive quality management is also related to the one that I mentioned before. So let's try to maintain the quality in advance. But when you see the procedure about the managing the quality, there's a process and then actual operations or maybe product development with that process. But mostly, most of the quality management method is highly focused on the last part when they're delivering the product to the end customer or maybe in between the process. But we want to managing the quality in the product development process in the stage, the most early stage, so that we can actually maintaining the quality in advance in advance, like much earlier than the existing quality management method. You can see the Janssen's, the example about the continuous process. When you make the continuous process compared to the batch process, actually they can maintain the quality, managing the quality much better, and they can actually monitoring all the qualities while in the real time, while they are operating their services and their stuff. So that's one of the good example. We can talk it out later on. So the motivation, let's starting to the motivation of the project that I want to present today here in this room. So the motivation about the project is about because of the characteristic about the South Korea. South Korea, we are highly reliant on the exporting the products to another country. We rely on a lot of GDP ratio to export product to another country, and there are a lot of proportions consist of intermediate. When you are selling the intermediate goods, then you have to be aware of a lot of circumstances, a lot of changes of environments. Like COVID-19, when it happens, 84% of the Korean company, they responded to the government that they had a efficient glitch. like a supply chain management is really hard if there is some kind of COVID-19 situation, or maybe sweat, or maybe some kind of happen from regroup or some other issues that might come up with our idea. So if it happens, then a lot of companies who are selling the intermediate goods, they are influenced by those circumstance changes. And it's really tricky and it's hard to control it actually because we are not the decision maker. They are not the decision makers. It happens like naturally, or it happens from the political issues, or it happens from somewhat reason that we cannot really predict in the future. So based on the uncertainty, the full of uncertainty of the global business era, that's why we are proposing the AI-driven demand forecasting method by dynamic scenario planning, so that we can actually we can actually prepare this what might some happening like in the future, because we never know what kind of things can happen, like tariff issues like currently ongoing. And I heard about the South Korea, they got an agreement with the United States about the tariff ratio as 15%. Well, that might happen, or maybe like a 25%, we never know. Like if there's any kind of political issues or something, or maybe like COVID-19 incident, that kind of thing might happen as well in the future. Maybe like a global, maybe depressing, maybe something like that might happen in the future as well. So that is the biggest motivation for their study, because we never know about the future. And then intermediate goods sellers and the exporting company, they are highly influenced by those kind of very exogenous issues and their environments. So that was the motivation of the study, the project. And so that's the reason why we are performing the dynamic scenario plannings and then AI technology and machine learning algorithm at the same time. And that was the reason that I mentioned. And basically, intermediate goods, it has some kind of characteristic that I mentioned. So if you are selling the product, intermediate goods has a difference in between the B2B context and the B2C context. Because B2C context, you can just measure about the preferences from customers or things like that. You can approach in that way. But about the B2B context, if you're selling intermediate goods, usually it's sold by the contract, or if you couldn't sell all the product, then maybe it goes to the spot. So that's the reason why we perform not just like a normal forecasting method, because this is a B2B context and then intermediate goods. So we had a project with the Korean company. So one of the biggest South Korean company, they are selling intermediate goods, and mostly they are exporting to another country. I mean, there are some of the proportion of their selling conducted from South Korean company as well, but mostly they are selling in another country, abroad. So that's the motivation of this project, and about some of the characteristics about intermediate goods and B2B context. So the pre-process for dynamic scenario planning. Starting from the project framework. As you can see from the photo, you can see like a machine learning algorithm or scenario creation by GAI, and the dynamic demand forecasting. When you see those machine learning algorithm and then GAI, what's the reasoning why using it for the dynamic scenario planning? Is because the dynamic scenario planning is based on system thinking. And the system thinking is some kind of concept that we are thinking about, like a lot of things that might affect some them result in a very a complicated way, and that they all connect each other. So maybe some of the parts reinforce the result. Maybe some of the parts has a feedback loop or something. So you can actually figure out when you figure out the result about if your Y value, imagine that if Y value is sales, then there are a lot of things might affect on the sales. So we are actually filtering the variables that might affect on the sales with the machine learning algorithm, and then from the framework about the dynamic scenario planning. So when you can see from there, I don't know if I can use later point, but uh, oh yeah, as you can see, the later point it shows the machine learning algorithm. It shows like the GDP, ROI, or cost, or something like that that might affect some of the demand. We can actually filter the variables that might affect on the sale or demand. And then we made it as like a GAI, and we conduct GAI analysis for creating this scenario. So the system dynamics, the stock and flow model, it creates a demand, and then based on this demand, when you're using GAI, then you can create the scenario so that there's like a neutral scenario and like a optimistic scenario and a pessimistic scenario. So that was the basic concept about our DSP. And about the whisper cycle, this is the one of the like a feedback cycle that we use so that we create a model and then we get the feedback from the expert from the company, and then we reinforce it and then we make it better and better and better. So this is some kind of framework that we conduct like for continuously, like it's like a continuously improvement. So the key concept about the framework, I'm gonna skip it. If you have any question, and then I'll answer later. And the project framework is the most important thing about this is system dynamics model. So system dynamics, we use the banking software and the stock and flow model. As you can see, there is cumulative sales and the annual sales on the screen. And then we use the vast repurchase model. The reason why we use the vast repurchase model is because when you use the vast model, you can see if the product portfolio is going to be good or not in the future. When you actually using the vast model, like maybe in 2050 or 2000, maybe 100, then you can see some kind of curve. It might look like a logistic curve that if the product is ongoing, it's going well, it's going to be sold very well or not. That's one of the reasons we conduct the VAT model and the repurchase model. And actually, we haven't really checked about the like a long-term effects about the system dynamics model to see whether the VAT model is it's on the way or not. But we use it for the like 5 years or 6 years of the demand forecasting. So as you can see from the screen, there are like the things that demand shift drivers that might affect on the demand. And the most important thing that we want to see is the annual demand. If those things, the model, the conceptual framework, and the model itself, and then the drivers, if it catches the annual sales very well or not, that is one of the key concepts of this model. And when you can see, there is a repurchase sector, and also there is some other potential demand. So you can see the M of the best model, and then P from this, and Q from the drivers about my effects on the demand. So those are the things that I explained. And we also use the machine learning algorithm to filter the variables because those things, what is it called? The variables that might affect some of the sales, they are usually affects on a way that no linear way. If it's a linear way, then it's going to be very easy peasy to like a forecast the demand. But because of the the complexity of the world and the business era is very global, and it affects on like many political issues or some other thing. So we have to think about it, whether we can actually deal with these issues very well or not. So we use the machine learning algorithm to handle this situation better. And about the lasso filtering, and so this is some of the process that we filter the variables, and we conduct the lasso regression, and then we also use the ranking matrix, whether the variables is significant or not to the sales. And then we conduct the PCA analysis to press the meaning of the variables. So the influential diagram, I already explained about that. This is conducted from the VAST model, repurchase model way. And then the result, it shows about the US market. So we checked out whether the US market sales we predicted well or not. So as you can see from the bottom, the MAP, the mean average percentage error, it shows like a 1.6 or something. So that you can see the result came out in a way that maybe we can use in the practical way very well. But we need to test it out because we use the calibration method from Belgium software. And then we use the thing that what is it called, the copy thing to figure out whether the model is working well or not by the calibration method from the Belgium software. But if you want to test it out, then we are thinking about to make a comparison among a lot of forecasting methodologies. Like maybe we can start it from the very basic prediction on regression or some other machine learning algorithm, or those other things that are candidates to figure out whether this model is better or other existing forecasting methods better. So we are still on the product level, but we want to move on to that level. And we also use the AI scenario creation as well. So even though you have like a neutral shape of the prediction from the stock and flow model, the dynamic scenario planning, but still you need to think about it, whether if the what's it called? If the economic situation going down, or maybe we never know, maybe economic situation gets better in the future. So we can actually figure out from the GAI creation. So we're using the LLM method because they have a huge computing power. So whether we can figure out the future scenario better or not. So that's why we use the GAI to create some kind of scenario. As you can see, the green one is the optimistic, blue one is the neutral, and the red one is the pessimistic way. So you can see the value from this graph. And we also use the market share analysis. Actually, that's one of the biggest point about this study. It's because there are many, as I know, there's no study. They make a comparison. They are combining the market share model and dynamic scenario planning together. So firstly, we measure the total demand of the market by the dynamic scenario planning using GAI. And then we figure out whether the firms, the demand and the market share, how much and how many can they sell. So we use the market share modeling, and then we use the attraction function. The attraction function is basically based on price. So and I mentioned about the B2B context, and if you're a seller about intermediate goods, then there must be some sales will be conducted mostly from the spot contract and mostly conducted from contract. And if there's leftover, then it goes to spot. So that's why we use the price of the spot and price of the contract. And then we measure it by the exponential. So exponent estimation. And we also, bless you. And then we also use the like a D, which is control the domain events variable to fit the parameters much better. So we conduct the parameter estimation and check the market share value. And the result of the model with the price scenario as well. So as you can see from this form A market share, but it differs from the price rising scenario. So as you can see, if the price rise like a 3% annually cumulative, then the market share will probably goes up 1.7% more or something like that. So by the market share model. And we also conducted some micro analysis of the project. I'm gonna go really quickly about this part is because this is some kind of additional analysis. So we figure out whether the firm, how many goods they can sell in the market by the B2B context. So, but if you want to figure out whether you can use this model much better or not, we need some kind of micro analysis as well. It's because we need to see whether other competitors are doing well or not in the market. And then we need to see what kind of market condition differences in the future. So we use the chrono model to figure out whether our competitors are doing well in the future or maybe we do well. So we conducted like chrono model, but because of the restriction of the data, we have to use the like existing market share data into cluster structure by the like inversion of the first order condition. So we obtain the cost from other companies, the competitors on the market, and then we put it into the original, the chrono oligopoly model. And then we estimate the alpha and the beta of the inversion metric, price matrix, inversion price function. So these are the model setup. If you have any question, we can talk it out later. And then the result, it shows in a way the product price trend with the product price trend and the form A to form F. So you can see there are like a lot of competitors in the market. When you conduct the existing data, the real data set as a chrono model, then it shows the market share differences. But if the price of the goods that we conducted is just ongoing, it has no difference in the future, and it shows like that. But if there's a price difference, then you can see some of the difference of the market share. And if the price it goes up to like 3% annually, then the changes of the market share, it goes really well. It goes really high. And so those are the one of the reasons that we wanted to figure out whether the market share will differ or not in the future by the pricing rate scenario. And about the quadratic programming, it's about the portfolio management, like a portfolio optimization. Quadratic programming, the QP is one of the very basic OR method. And then we wanted to figure out, we talked about difference and then characteristic about the B2B context and intermediate goods. Usually the sellers, the suppliers, they make a contract with their customer, the buyers. And those are the reason why we need to conduct this method to figure out whether we can optimize the portfolio or not, because most of the selling is consist from the contract. So the contract, if the customer, the buyers, if they request us more, then maybe we need to change our order fulfillment ratio or things like that. And because of that, there must be some safety stock. And then also there are some issues from inventory management, and those will be very costly. That's why we managing the portfolio, and then we wanted to figure out what is the optimum channel distribution about like a spot or contract level. So that's why we conduct that, and the result shows in a way that we should focus on the first tier channel and the third tier channel if you want to reduce the spot and the safety stock level. And we can talk it out about the results later on. So about the discussion, those are the things that we have done so far. So basically, we forecasted the demand from the market first by the dynamic scenario planning. And then we use the market share modeling to figure out whether the firm A how much they can sell, how many goods they can sell in the market. And then we conduct some micro analysis, whether the market share of the market will be differ in the future or not by the price rate scenario, and about the portfolio optimization by the channel. So that whether we can save some safety stock, or maybe we can save some cost from the inventory cost, or maybe some of the issues while we are conducting our business. So key takeaway, we use the bespoke loop, the dynamic scenario planning, and the result came out like a 1.6% of the MAPE. And then you can see we also conducted some micro analysis. So thanks for listening. And if you have any questions, let me know. And these are the four that we went to like a conference together. You can see Professor Lee and Professor Lee. I'm sorry that I'm pointing with the razor, so it might seem rude, but yeah, we went to Microsoft together, like Professor Lee and Professor Lee together. And even like from 2018, Professor Lee was with us. Like our relationship is very long, like 7 or 8 years, more maybe more than that, and could be longer in the future. So yes, thanks for listening. And if you have any questions, just let me. Okay, can go on.